How's it going? This is Dr. Schulman, and this is for Math for Teachers. And we're going to go over media and social media today. Hope you're as excited as I am. I think media and social media are like the biggest things affecting everybody right now, right? Just think about how much time people are glued to their phones. So that's kind of like how can we get through to students? It's through media and social media, and this is what I really think. So I'll share a bunch about it. This is a great assessment if you'd like to do it. So I'm sharing my screen. Um, and we're here at media and social media. There's a couple more in this one. And here's the link. So now the way the media likes math, they don't. They always could portray it in a terrible light, you know? We can think about this YouTube video where they just rag on math all day long, right? You can watch it. It's tough. Here is a another way. It's like a bothersome light. Here's one you might not have seen, which I think is interesting. So many clips.
There are 5 goals for the third quarter. Patrice has a meeting in 10 to share her 5 goals for the third quarter. She doesn't have time for more numbers, so she reaches for a creamy, delicious ratio. For less calculation and more satisfaction. Ratio. We do the math, so you don't have to.
Ouch. How much does that hurt us?
Patrice has a
You
meeting
know, and like, look at this. How rough, right? This nebulous, crazy thing. You know, even something as short as a 15-second ad just shows how rough it looks like for uh everywhere we are in the media. So this is a great article. He's a lot of ideas from this. Numbers and Nerds, portraying mathematics in children's media. Now, I took a lot of ideas from here. It's a great article if you want to read it. But it just talks a lot about mathematics is typically portrayed as a difficult subject area that is only accessible by a few. You know, like we got to rally against this somehow, right? So it's either negative, bothersome, or just altogether just out of it, you know? So whether in films, advertisement shows, memes, or socials, media has a way of disseminating these stereotypes that lead students to shy away from the discipline and not formulate a strong math identity. In terms and math identity, I'm still going to use Crossley's definition in terms of self-confidence, interest, and utility. The mathematicians used in the media are often characterized as one-dimensional or surface-level caricatures. They're cold, eccentric, autistic, strange, or have some supernatural abilities to rattle off these crazy computations. These often crazy-haired number files can be difficult for the typical student to relate to, right? If we just show them real people doing it in their jobs, I think math would not have I don't know, such a bad connotation. So the authentic stories of historical struggles to create a mathematical content or the people behind the theorems are often never revealed or shared. So this is a big piece, something that I always want to relate to my students. The stuff you're learning took people lifetimes to create. You're expected to learn it in a day. It's okay if you struggle. They struggled making it. So mathematical content can be rife with errors too, like our favorite in The Wizard of Oz or the disagreement in order of operations in Abbott and Costello. So in The Wizard of Oz, he gets the Pythagorean theorem. He says it's something else. And in Abbott Costello, they don't know what's the order of operations. So while these errors can be used for potential comedic effect, sharing such inaccuracies to mainstream audience can create difficulty. So this is another really great article. I wish I could get published here, but you know, everybody has their own you know, their own goals. So this is incorporating popular media. This is from the show Numbers. We use math every day to predict the weather, to tell time to handle money. Math is more than formulas and equations, it's logic, which is great. We've got memes, we've got movies. I want to show you the mistakes. So this was the sabotage episode where they use numbers. which is a great problem to share with students. And this is from the October Sky movie. They launched rockets and failed, so you can do this problem. And here's the one I was saying, the Abbott Costello problem. Also, this is a meme problem. Use parentheses or brackets to solve it. It had 20,000 retweets and 15,000 comments. There are two answers. Do you agree or disagree with the problem? Here's the mistake in Wizard of Oz that always comes up. The sum of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining sides. It's actually a right triangle. I believe they used isosceles because it sounds fancier and more mathy than right. But it's wrong. And this is in the Navy where they mess it up too. Great job, right? So if you want to do these problems, they're great. I think they're really useful. We can do physics of the hair of Tangled, Moneyball, which I really like, the Jonah Hill Brad Pitt movie, where they have the ratio runs scored squared over runs scored squared plus runs allowed squared. So it's 1 over 1 plus runs allowed runs scored. This is their basic win ratio formula. So I think it's a great article. Feel free to read it and look through them. So they talk about Moneyball to explain the formula to value of players to produce wins. We got Hidden Figures to show representation of different cultures in the mathematical fields. However, math errors can lead to some of the most iconic characters in media. Our good friend Popeye. So they messed it up. They don't have the decimal in the right place for spinach. Apparently, they think that spinach has how much iron in it? 32 grams. Oh my God, that's insane. That'd be like eating a nickel, I think. So they said it contained 35 milligrams of iron instead of the actual 3.5. It was not corrected for 67 years and required a full debunking. However, people still think spinach is super good for you, but it's just as good as probably any other vegetable. Sorry, Eric. It's okay, Poor Eric mistakenly published that it was 35 milligrams instead of 3.5. So whether taking stuff from a news article, a box score of a sports game, an advertisement for a car or film, current media is flush with numerical values, symbols, tables, for luggage for the, oh yeah, so these are great ideas. So this is a great way to see like technology using math in the future. So there was a 3D printed human body in Texas University, and they used it to test experimental cancer treatments, which I think is cool. And then I just said the same thing twice. And there's also recyclable 3D printed clothes to eliminate the need for luggage. So these two articles are great. So there's the 3D printed person. That's cancer treatments using cellulose in Texas. Here is the clothes. I think the clothes actually look really cool. So it was supposed to be recyclable clothes that are 3D printed, and the main application was to like not have luggage on airports, so we can use it. Okay, whatever. So there's a video about it. I thought it would be a cool picture of the clothes she made. She's an Israeli fashion student who made them. I'm always trying to support people who I like their clothes. The pictures aren't here though, which is a shame. Probably because it's such an old one. Maybe if I try to reload the page. You never know. Well, we could just look up the designer. But you could read the article about how she's using 3D printing to make it, which I think would be really cool for students to see. 3D printed clothes. There it is. So these were some of the designs that she made. Right? Isn't that cool? Isn't that a cool jacket? So the whole idea was to make these clothes that you could print from your hotel room, and then you recycle it at the end when you're ready to leave. And that way we wouldn't need to waste all this stuff of moving luggage around. Okay. There are lots of pre-made lessons. Oh, sorry. And then video games created by artificial intelligence. So this is a game made by AI. And there's tons of them where you let the AI watch old school video games and they create their own. This one was called Death Walls. Hey, I made this. You're this little blue thing. Oh no, don't touch the red. Nah. So I don't know, it's pretty fun to figure out how to actually do it. Okay. So just a way to like incorporate, right, three-dimensional shapes. Why not show them 3D printed clothes or 3D printed people, right? Crazy. So Yummy Math, I like a lot. Yummy Math uses all of these things. I guess you have to pay for it now, but that's okay, right? At least they do everything based on what's happening. Donut Day, Mother's Day lessons, Earth Day lessons, Valentine's Day lessons, Pi Day lessons. So you could just make it really current. I know they have stuff about holiday movies and trailers. I've used a lot of these things. And the best part about it is they have the Common Core standards on the bottom. And I know they do this by grade, which is nice. Third grade, numbers and operations. How much chocolate scoops do I need? Magic squares, a whole lot of cookies. Someone ate my cake. I don't know. I think they're nice. So are they all? I guess some of them are free. Nice. No, some of them still have it, which is great, which is free. But they try to be as current as they can with the information, which is why I like Yummy Math. Media for math is great too. So this is a library of digital math resources that have all these pieces, and I know it's all of it is free, which is great. And then we've got these Google Earth Voyager stories, which you can totally play if you need to share more. I like the one about prisms. That's cool. Ooh, this one's cool. This is a triangular prism. So if you want to show them a triangular prism, if I can get rid of the ad. Okay, here we go. Let's see. So this is part of a collection of Voyage series. Click on this link. We got the teacher guide here. This is geometry of city planning, circular structures, architectural prisms. This is all the stuff that is free and you have access to. Isn't that nice, right? There's all this free media out there to help you make the math more accessible. Okay. Let's just see if we can watch something. See amazing architecture examples of 3D prisms. Go on a tour of New York City landmarks. I'm gonna try that again. This one just looks fun, you know? Maybe if I click this link, it'll bring you right to the video. Triangular stories. Oh no, this just brought me back to all of them. What if I click triangular prisms? It's not the most user-friendly website, but it has everything I want. When I click the Google Earth, I thought this would be a video. All right, I don't need to see the help center. Oh, this table of contents. Whoa. Oh yeah, I was in the right place. So they're going from Earth all the way to the Flatiron Building. That's cool. And let's see what the video has to share for us. Oh, they do a wind simulation. I really like simulations. They're great for students.
Hi, I'm Doug Platt, and this is how to architect the secret to crazy wind at the Flatiron Building. The Flatiron Building is located in New York City and was completed in 1902. It was designed by Daniel Burnham and originally called the Fuller Building after its builder. The colloquial name Flatiron sticks to this day because the building's shape resembles an antique iron. The shape, as you'll see later in the video, created quite a stir when it was built. The Beaux-Arts style of the building is iconic and a favorite of photographers and filmmakers. The building was a product of the Chicago School of Architecture and inspired by ancient classical precedent. The facade is organized in parts, like a Greek or Roman column, with a base, middle, and capital. The building is made of steel and clad in limestone and terracotta. Ironically, it wasn't appreciated by everyone for its ship-like appearance at the time it was built. And unless you've ever visited the site, you wouldn't know that the site, together with the building, generates strong winds. That's because of its location. It sits between East 22nd and 23rd Streets, splits Broadway and Fifth Avenue, and resides at the end of an open corridor created by Madison Square Park at the north. Wind was such an influencing factor when the building was built that engineers designed it to endure winds 4 times stronger than might be generated on the site. In fact, police in the area were oftentimes forced to tell men to stop loitering as they tried to get a glimpse of women's bare ankles as their skirts were forced up by the unpredictable winds. As you can see from the wind simulations by my friends at SimScale, the winds generated on site are strongest from the north, indicated in red. As these wind gusts reach the curved front edge of the building, they create accelerated wind flow and vortices. The wind flow acceleration around the building is highlighted in this 3-dimensional close-up, as indicated by the yellow, orange, and red volumes. The curved front tip of the building, as seen in the next color simulation, clearly creates high wind speeds. These in turn cause vortex to form and sudden wind flow changes that are particularly strong on the Fifth Avenue side. What's really cool about these simulations is that they're available to everyone. As you might imagine, complex simulations like these are really expensive, especially for a small architectural firm like mine. But SimScale makes them available, minor results being from the community, or adapt an existing simulation for your own use, and they run work.
All right, so that's pretty cool. Yeah, SimScale I've used before. It's a great resource. But that's just, if you want to explain triangular prisms, you can use Google Earth and actually show some videos about it, which I think is great. But now we go to social media. Oh, sorry, Radical Math is a social justice-based one. I feel like I spoke about it in the last one, but it's a really good resource as well. So social media can be a controversial path to get students engaged and motivated in math classrooms. Social platforms dominate students' attention spans on a daily basis and can be a useful way to foster student initiative in mathematical work. Showing a YouTube video on how to solve a math problem. This is my good buddy, organic chemistry teacher. Helps me when I struggle with stuff. Or share a funny history of mathematician, the history of Pythagoras. So the ones that I always use, I use Byheart. She's great. I use organic chemistry teacher, and I use Nancy Pie. I think those are the best. So can seem harmless, but there are specific challenges for employing any levels of social media within the classroom. The dangers of inappropriate content, age restrictions, and relationship boundaries are ever present when attempting to incorporate this platform. So I don't care if you're using Twitter or anything else, you got to be very specific. So an educator should not only take the time to teach students about the dangers of socials, but you also determine if using such a platform is beneficial to their learning experience. In addition, ensuring the proper permissions of the parents, the admin, supervisors are obtained before employing socials is necessary. One potential method for designing curriculum or utilizing these resources is providing all the materials, links, and lesson plan ideas to the families of students and the administration at the beginning of each year, semester, quarter, or unit. I've always done this. I've always had like everything kind of ready because I'm a planner and have everything be like, these are all the stuff I plan to use, even if I don't plan to use all of them, just to be transparent, make sure their parents feel safe and the students are not going to be exposed to anything negative or out of the ordinary while enrolled in the course. So how can you use it well if you want to use social media? So if you want to use social media, here's a great article. Obviously, I've got tons of articles for seeing this used in the math classroom. So social media in the math classroom, if you want to read through this one, it's really good. Google Earth is the one we're looking at. Data visualizations, Tag Galaxy, these are really good stuff. What else do I have? So this is an article. I have 2 articles by Krutka, and Karka basically just does social media math. So the positive elements in social studies and the use of Twitter to understand current events in the news, that's something they did. The raw numbers produced by YouTube. This is a great one. Meme ratings as number generators, graph theory with Facebook are all possible options. So these are the ways you can do it, right? These are full lessons that are already done that you can take a look at. Another option is having students create Twitter handles of the past mathematicians, which I think is super cool, and respond to one another as if they were that mathematician during the time they lived. So make one Pythagoras, have one person pretend on Twitter to be, I don't know, Gauss, and have them chat. This idea was based on a social studies class project using either online platforms. So here's an online Facebook one of, it looks like Hamilton, or not online representation. So this is a Facebook of a pharaoh, which I think is really cute. So you could always have students do one of these, or actually do an online one, in which schools created profiles of historical figures and correspond to another. Another option is that students can instead look up current mathematicians' YouTube pages, websites, or handles and reach out to them about their discoveries on what they found. Another option could be making a past mathematician be real. Now, I didn't know what Be Real was because I'm an old man, but Be Real, this was is a website. And here's an example from one of my history students who did a really good job. She made a Be Real of, I think it was Lincoln. Yeah, so this is her Be Real from Lincoln, about to be the 16th president. I had to take in this and know my address, and she just used to explain this. So I think it's pretty cute. Here's a social studies example of Twitter. And there's the one on ancient Egyptians. So basically, you can find handles using images and text to help students understand how the mathematician lived and the reasons for their discoveries and how theorems were useful during this time. The students could respond to one another or the public as if they were that historical figure, or just create the page as a poster board using the layout from the social media platform. So this article is just about benefits. I think it's really well done. It's just different benefits of doing it. So the benefits are building relevancy, right? In addition, as an educator, you can create your specific teacher social page like Instagram, YouTube, Facebook, blah, 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 for interacting with parents, students, and contain homework help or lesson links. I'd rather just do share the Google files. These are some options for incorporating social media, but be sure you have parental and school consent before using them. All right, so that was a lot, right? So what do you have to do? So you get to look at 3 and rate them. Isn't that nice? So I gave you 3. We're going to look at them together and you get to rate them. So the intro, have you ever experienced elements of media in your previous or current math classes? Do you do video, current event news articles, right? Have you experienced that? What are your thoughts about using media to teach math? Would you utilize media in your math classes? What are possible benefits and other advantages besides just motivation? And what are the drawbacks to using it? So here's the review. Although there are many concrete methods described in the articles, you will have the opportunity to delve deeper into one of these. So you pick one of the 4. Pick one of the 4 and see how it was used in different ways. So the first one is Dime Heist. This activity was by Dan Meyer. I got to meet him at some conferences. Genius, in my opinion. So after a Philadelphia heist, here's the news article in which $200,000 of dimes were stolen from a truck. Dan created a guide on how to structure an effective math lesson. The story reports on so this is from his blog, of the truck were too heavy, causing the thieves to spill many on the road and need to change their plan of transporting all the dimes because they were stealing these dimes. They were too heavy. The goal is to use estimation and conversion to determine which coin would be the best to steal. So how did I do this in my class? The first thing, I had them actually read the article. That was the first thing we did. We read the article, right? Nothing too crazy about that. Then we did the lesson. So here's the lesson. And we've got the ratio of each coin. So that's the value to its weight. And that's one way to do it. And he's just saying why he has two versions of this and why it's better to just do it with the coins first. And then talk about were the diamonds smart or not? What could you have been a smarter coin to steal? Which coin do you think is the heaviest? So basically just talking about the coins first before doing these pieces and having them think about which one's the most valuable before they actually try to steal them. I think it's a great lesson, right? I think it's a really good lesson. If you want to do this one, have fun with it. The next one is reflection angles using a protractor. So this is based on a Patterson activity, and Patterson has this entire life on YouTube. It's probably one of the best geometry teachers in my estimation. Everything he does is great. I'm such a big fan of Patterson. So you could watch his video. So what did I do? You begin by so this is how to use a protractor, right? So they get to watch this Donald Duck video. Whoa. So they get to watch this Donald Duck video. I'm just trying to find.
Somebody discovered the magic of these proportions.
But you obviously don't show them the whole thing.
Proportion is to be found in life itself.
Here we go.
Uses his.
So you show the whole part about billiards.
Yes. The ball not only has to hit both the other balls, but it must contact at least 3 cushions before it hits the final ball. This game is precise calculation. He figures out each shot in his head. He could play it like this, but it calls for quite a bit of luck. There is a better choice. For this, he uses the diamond markings on the rail as a mathematical guide. First, he figures the natural angle for hitting the object balls. And then he finds that his cue ball must bounce off the number 3 diamond. Next, he gets ready for the shot, and he needs a number for his cue position. This calls for a different set of numbers. Not when you get the hang of it. You see, the cue position is 4. Now a simple subtraction. 3 from 4 is 1. So if he shoots for the first diamond, he should make it. It's called playing the diamond system. Angle 2. Cue position. 1.5, 2, 2.5, 3, 3.5. 2 from 3.5 is 1.5. So shoot halfway between the first and second diamonds.
It's a longer video, but I think it's really cute. So students get to watch this, and then they get to try this. And this really helps them use the protractor and the ruler. So we have to figure out, because that's old, like ours are like, we play pool now with the pockets. So it's like, how can we figure out using the specific angles how to get the cue balls in the pockets? I think it's really great for students. So this is going to go here. So there's the angle. So we know the exact other angle needs to come up. Will go in the pocket. So method 1, we reflected the hole. Method 2, Method 1, we reflected the hole and the ball missed, sadly. Method 2 reflected the ball and the ball missed the hole. These are just 2 simple ways to determine the same result. But basically, we want to, how can we actually do it? So here's the double bank. It's just kind of showing you different ways to see it. Here's it happening. Strike the ball at the center, no spin. But basically, whatever you're going to hit the edge, it should be the exact same angle coming out. And then what do you get to do? You get to try it. You get to see if you can bank these in. Now, because whenever I've done this with my students, they got frustrated. So you might get frustrated yourself. I have a link to the answers. Isn't that exciting? So here's the first 2. First one is yes. We hit it. Boom. Same exact angle here, going up in the pocket. The second one is also a yes. So if we strike it here, it'd be the exact same angle coming out. I'm not going to show you the rest. Hopefully you try it yourself. All right, so let's do another one. So this was using research and interviewing. So this is based on an article by Houghton and Dawson Threat in 1999. They're classes of college algebra students. In this activity, the students have to determine their future role, job, or position based on their major or future major. The students conduct research on their ideal job and find at least 2 articles from different media outlets with numerical values, statistics, or reference math in any way. Ideally, how math is used in the job, whether it's nursing. I have a whole one on architecture, advertising, etc. The students must then reach out to a professor in their future field, and you can professional in their future field. And the interview must surround how mathematics or numbers are used in their job. And the project concludes with students sharing their findings if they feel math is necessary in their future job. It's just an authentic task for students. So what would you do? We would try it, right? You'd actually carry this out. Which job, find 2 articles, and then do an interview. The last one is where you watch clips from the movie The Man Who Knew Infinity. And you get to learn about Srinivasa Ramanujan. And then you complete this one from Alcozy, which is great. So students really like this because one, you get to learn about the person who made a lot of the math theorems we use today. And they answer critical thinking questions, and then they figure out pi by doing just measuring the circumference and diameter. When they divide it, they have to get as close as they get to pi. You can make your pi as big as you want, right? But the closer you get to this value, the better measuring you did. So I always would bring in a bunch of stuff for them to do, and then you get to do it using a compass as well. So these are 4 ones that I think are really good, right? So what do you got? You have a news article and a blog post. You've got an old school movie, right? And playing pool. You've got news articles and interviews, right? Or magazine articles and interviews. And then you've got clips from an actual current movie. So you get to review the links, select one, describe the activity in your own words, explain why you chose the activity, rate the activity's use of media, rate the learning this activity ability to teach math content, what elements to add to make it better. You can make all this better. Describe benefits and drawbacks to doing this activity in the classroom. And would you use this activity in your own classroom as is, with modifications, or not use it? So you get to try one yourself and really relate on it. And then you get to make your own. So you want to make a media lesson or activity. So you specific the class and grade level, you take the standard, design your own based using either video, current events, or whatever. Describe the directions in detail, explain how you're going to assess it, explain why you chose it, describe how the media improves your understanding, describe the benefits and limitations to your activity, what modifications could you do once you're trying it, and after you reflect about it, like, would you change anything? And then for social media use, it's just basic, like, do you plan to teach your students about the dangers of social media? Is this your job or not? Do you plan to incorporate social media in your classroom? Explain your reasoning for why or why not to use the platform. If you plan to use it, how will you use it and why? Will it be online or referencing it, like making the fake Facebook pages? What safeguards will be in place? How will you get the approval? And then finally, you get to reflect on it. So explain what it was like to complete the assessment. Did any of your thoughts about social media change while completing the assessment? Do you plan to use social media in your future classroom? Describe ways to improve or alter it. And if you were to create the assessment for pre-service teachers, what would it look like? These are the principles. Notice this has the smallest amount of in-test standards that you cover. However, I think this one's one of the most relevant. Now, if you are going to be doing this, here is the rubric. I think it's out of 12 points. Oh, no, 18 points. Why is there more? There's just more here. So the first one is the introduction. So is it clear description of media use and benefits and drawbacks? Now for your activity review. So is it a detailed account of the activity with ratings to teach the media and use to teach the content? So your review, then it's the media-based activity lesson. So did you do a clear and detailed activity with assessments, the standard expectations, and your own I said the same thing twice. Sorry about that. Now, is there for social media use, is there a clear decision and reasoning for why or why not to use social media in the classroom? Your reflection on it, and then finally the formatting. Obviously, I take these reflection pieces seriously because they help me tweak these. I'm constantly changing them to make them the most useful for students. So you chose to do this one. I hope it's interesting for you and fun. And let me know if you have any questions about it. Have a great day.